For our fourth and final shuffle for this particular video, we're looking at shuffle 28. It's also a push-off pairs, but the stacking is from right to left. So let's go ahead and derive the permutation for this shuffle. We begin with our cards numbered 1 through 8, and we'll perform this shuffle. So it's a pushing off of pairs, just as we saw before. So push off 2, push off 2, push off 2, and then the final 2 go right there. Now the stacking is the fourth pile here gets stacked on top of the third. That new packet gets stacked on top of pile 2, and then that set of 6 cards gets stacked on top of pile 1. So recall this is pile 1, 2, 3, 4. So let's go ahead and do the stacking. So 1 goes on top of 3, 3 goes on top of that packet of 4 goes on top of 2, and then this larger packet of 6 cards now goes on top of pile 1. So what is the new ordering that we get from this shuffle? Well, it's the following: 7, 8, 5, 6, 3, 4, 1, 2. Expressing this in Cauchy's 2-line notation, we obtain the following. Bottom row is 7, 8, 5, 6, 3, 4, 1, 2, which agrees with what we just obtained. Converting Cauchy's 2-line notation to cycle notation, we obtain the following. 1 goes to 7, so we have an arrow from 1 to 7. 7 returns to 1, so we have an arrow that wraps around. So that completes a 2 cycle, or in other words, a transposition. So 1 and 7 just switch places. 2 goes to 8, so we have an arrow from 2 to 8, and 8 returns back to 2. So that gives us a second 2 cycle, also called a transposition. 3 goes to 5, so we have an arrow from 3 to 5, and then 5 returns to 3, so that completes a third transposition. And finally, 4 goes to 6, and 6 returns to 4, so we get our fourth and final transposition. Color coding the digits, we obtain the following. And as a quick reminder, we color code the position values 1, 4, 6, 7 black to distinguish them from the position values 2, 3, 5, 8, because these are important sets of position values in the study of Bessey sequences of order 8. So we can see that inversion has not occurred because black 1 goes to black 7, which gets sent back to black 1. Red 2 goes to red 8, which gets sent back to red 2. Red 3 goes to red 5, which gets sent back to red 3. Black 4 goes to black 6, which is sent back to black 4. So each value gets sent to a value of the same color. So here, inversion does not occur. Recall, inversion occurs if the cards that originally began in positions 1, 4, 6, 7 get moved to positions 2, 3, 5, 8, and vice versa. If that happens, we say inversion has occurred. But that hasn't happened here because all of these position values in set A are sent to position values within set A. And the same thing for A complement. All of the position values here, 2, 3, 5, 8, are sent to values in A complement. So we're looking at this situation right here. And that's what's indicated in the top right of the bottom row, right here. So no inversion. So let's go ahead and show you that inversion has not occurred using our Bessey sequence 1, 0, 0, 1, 0, 1, 1, 0. So if we perform this shuffle, we should get back to that same form. So let's go ahead and we'll push off 2. We'll push off the next 2. We'll push off the next 2, and then the final 2 go down as a pair. The stacking is from right to left. So we're just going right to left, building up a larger and larger packet. Finally, these get stacked on top of pile 1. And so we should get back to the same structure type. It should be a 1 0 0 1 0 1 1 0. And that's the kind of organization that we began with. But it's very important to know that cards have indeed been moved around. So in particular, we see that what was in position 1 and 7 switch places. So this 1 used to be up here in position 7. So those switched, even though it's hard to tell here, right? Since we have supposedly identical labelings of just zeros and ones. I didn't quite succeed because this 0 is like a monster size, so you can kind of detect a difference there. 2 and 8. What originally began in positions 2 and 8 switch places. So this 0 here used to be over here, and this one here used to be there, and so forth. So cards have indeed been moved around, but they've been moved around in such a way that it returns the packet to its original Bessey structure form. We also see that this shuffle has order 2 because it's a product of transpositions. So if you perform this quote shuffle twice, it will return the packet to its original order. So that's something you may want to try out. Just perform this twice, and that packet 1 through 8 will be returned to 1 through 8. Looking at the shuffle diagram for shuffle 28, we find the following. 1 goes to 7, 7 goes to 1. So there should be a double arrow between 1 and 7. There's also going to be a double arrow between 2 and 8, a double arrow between 3 and 5, and a double arrow between 4 and 6. Okay, so we are now ready to go on to an application. Okay, so let's take a look at an application of these 4 shuffles.